going to introduce you to Google Colab, which many of you probably already use. I like Google Colab. I pay maybe $10, $12 a month because then you have more RAM, you have everything you need, but the free version is fine. But when you're using some of these client science databases, they are quite large because some of these are arrays with multi dimensions. So this is where you find Google Colab. What I like about Google Colab is I can upload files very easily so that when you're writing your code, everything you need is right there. And you have notebooks to execute even if you close a browser tab. So it's really nice things. You don't have to go in all whole hog right off the bat. Just start using it, the free version. And if you see resources you need that aren't active, then you can pay for these as you go, which I think is a nice way to go with a lot of the tech stuff. So, what I have here is you can see this is the downloaded data that now I can just copy the path and put that right into my code. And I also wanted to show you other things here. You can save a copy over on GitHub. You can put it in your drive. And there's a lot of use cases for that as well. Now, XRA is the package that I want to introduce you to. If you haven't used multidimensional arrays before, this is a nice introduction. They have a lot of resources here that are very, I think, easy to understand. And they give you some of the information you need when you're uploading it to your work file. This is what we're using, the open data set. It's going to take that data, the netcdf data, from the website that where we've downloaded. It's going to open it, and we're going to get a lot of information in there. And I'm not going really deep in that, but because they have such a good resource, if you have any questions, you can let me know. But what you see here is the engine. Okay, this is the back engine that you need to run these XRA. So this is the stuff. netcdf4 is fine. I load everything just in case, and I'll show you that when we look at the output. So you're going to pip install it, and I'm just showing you here where the code is. You'll see it in the actual coursework. You can just copy it and put it into a notebook. And there's that open data set. This is what you write to get it to open the data that you want it to look at. And this is the GPP data that I was referring to. I think we described it in different places, but just in case you still aren't sure, look at the resources that I put there so that you can look at it. It's really just looking at the carbon sink and the flow of carbon in the environment and in the ecosystem. And we look here at our data set. What are we looking at? Well, we're looking at first, we see it's a pretty big file. It's 3 gigabytes. We have a month, 12 months of the year, 2 dimensions. They have easting and northing. This is west east, north south. So you might recognize that as longitude and latitude. And you can see the floats here, and you see the information that we're looking at, the time bands. There's 12 different time bands. The time is telling you they're taking them at the same time each day, each month. And the CRS, which you're going to need to know. And let's just go to the next. And these are those data variables I was telling you about, just more detail for you to work through. I defined a lot of the stuff you're going to want to understand, the gross primary productivity of biomass, and they express it as carbon. Very interesting to understand how this is utilized when we look at climate science. So now I'm installing all of this. I have my source CRS. I actually pulled that from my QGIS file because I also ran this in QGIS and looked at it there. I'll add that as a resource as well. And so you're getting all this information coming in. And now we're going to decide, how do we want to view it? So I just picked this figure size We have the slice. Remember, I told you it was sliced by month. And then we have this color mash that we've picked. These are things you can edit. And if you're confused with how to edit them, you just go into the user guides in the actual program that you're looking at, and they step you through all of this. And I didn't mention this to you, but I had trouble getting it to run, and sometimes with netcdf4 files, because I use them a lot, it just doesn't work with the pip install, and I have to go into my terminal. I'm on Mac OS, and I load the Conda package, and then everything is a miracle, and it all happens. So you just go in, and I set up my own environment. I have a minimal data science environment. It's a mini Conda, so it's not Anaconda where everything is loaded in there. It's very specific, runs a little more efficiently, and you can just see all the programs and the backends that load it with it. And I had some trouble with the mappable, the color bar creation. So I had to reinstall it, and then it was fine. And this is what you're looking at here, the GPP. And these are the higher rates as we have more carbon being pulled out of the environment. And I picked time index 0. You see here, what I'd like to invite you to do is try time index 5. See what it looks like in the summer. See what it looks like in the spring. For our purposes, I just pulled it out in January. So you can think about what the environment might be, and this is just more of that data. And this is reminding you that you can change this, right? This 0 represents January 1, 2, 3, 4, 5. And you could just put a month in there and just see how they vary.